Hi all, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to see how we can create our own image for MNIST dataset. So without any further ado, let me quickly walk you through today's agenda. We'll be starting this session by understanding what exactly is the problem statement and the workflow that goes along with it. Then we'll quickly look into the tools and frameworks that we are going to use, and finally we are going to jump down to our projects. So before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're someone who's looking forward for machine learning or deep learning training certification, the links would be given in the description box below. Alright then, so let us now come back talking about our project now. So over here, what we're going to do is we are going to download the MNIST dataset from keras.datasets, and we'll just take the X dataset. That is the features that are present only in the X train part. And what we are going to do is we are going to create a generator and a discriminator model, and then we are finally going to combine them in order that they can work together. And as GANs are being a pretty intense topic, I would really recommend you people to check out or have a good understanding of the real basics of what deep learning is and how machine learning works. Although you won't be using any concepts from the machine learning, so if you want the playlist for our deep learning or the full course link, the description for that will also be provided in the description box below. So talking about the problem statement, as I mentioned earlier, first off we are going to load our dataset, and the source that I'm going to use over here will be keras.dataset. Apart from that, we are supposed to create two types of model here. One would be the generator model, another one is going to be the discriminator model. Generator model, it is there for performing sampling, and the discriminator model is basically there for downsampling, and then we are going to combine this up. It's very important for you to know how GANs work, and the reason for this is because we have to write our own loss function over here. So moving ahead, let me quickly just show you what are the different tools and frameworks that we are going to use. As GANs are really intense when it comes to training them, we're going to need a good performing GPUs. So what I'm going to do is, we all know Google Colab gives me a good performing GPU for free. So let me quickly use that up, and we're going to use Google Colab. Apart from that, talking about the different frameworks and libraries that we're going to have, the generic ones would remain the same. We are going to use NumPy, Matplotlib, and Pandas. Apart from that, a deep learning framework that is TensorFlow and Keras, that's a framework that we are going to use here to train a model and also to develop our model. Alright guys, so now that we know brief of what we are going to do now, let me quickly jump to my code editor, that is Google Colab, and show you how we can get started with this project. So this is the interface of a Google Colab. First thing that I'm going to do over here is come down to the runtime and change the runtime type to GPU. Because training GANs requires a huge amount of compute power. So once we're done with that, let's connect this to the server. So it will take some time. So once this is connected, let me zoom in for you guys. First off, what we'll do is we'll load our libraries. So load libraries. So let's do one thing. Let's import from keras.datasets, import MNIST, and let me execute this. It's okay, we are getting this error. Let me quickly, I think I might have done some typo here. So first off, keras.datasets, import MNIST. So this is where I'll be having my datasets. Then we also need some layers. So it will be keras.layers, import. We know we have different types of layers. So for our simplicity's sake, I'll import all our layers over here. And then we have from keras.layers.activation or advanced activation. We'll import this later. So let me just have something like models, import sequential model, and then also import functional API, that is model. Now we also need some optimizers, that is from keras.optimizer, import Adam. And as you can see, I've done a small typo here. Let me fix this as well. And let's also add this advanced model again from keras.layers.advanced model. It's going to be advanced activation, import leaky ReLU. Usually the activation function that we would use in normal CNN is going to be like ReLU or TANH, but here we're going to use leaky ReLU. ReLU is just that, in the lower level. So let me show you what this means. So if I take this thing, ReLU goes something like this. Oh yeah. So this goes here and it ends at 0, and then there's exponential growth. So either it is at this point or at this point. But when it comes to leaky ReLU, the graph over here is going to be same over here, but on this coordinate it will be a small dip. So we have a small space here. So this is called as leaky ReLU. And apart from this, let's also get some generic ones. So import NumPy as NP, and also import Matplotlib as PLT. So let's execute this. That's great. What we'll do is, sometimes we do get the warnings. So let me ignore the warning. So import warnings. So now warnings, let me execute this. Then we have warnings dot filter warning and just pass here ignore. This looks great. So now we are supposed to get our data set. So for getting a data set, I just have MNIST, which we have loaded, and then we just have to do load data. We all know that this gives us tuple, two values. So that's xtrain, ytrain, and again xtest, ytest. So what we're going to do is we're going to have something in this format, and now we'll just have xtrain here. So now let me quickly execute this up. And now if I show you xtrain dot shape, it's going to be 60,000, and 28,28 is the picture size. And now what I'm going to do here, in order to normalize my image, what we'll do is xtrain is equal to xtrain minus 127.5. Divide this by the same 127.5. So print, we want the maximum value and the minimum value, that is xtrain dot minimum, and similarly print xtrain dot max. And now you can see it would be ranging from -1 to 1. If I divide this by like 255, then everything over here would be from 0 to 1. So this is what we have done. And now we're supposed to create the batches. What we're going to do here, we're just going to use the train images or the images present in this train to learn, and then we are going to generate our own very own MNIST data. So it will be total epochs. Let's keep it as 50. Then we have the batch size. Batch size basically means in one go how many images can be there. So it will be 256. Then we have half batch. That's going to be half of this. That's 128. And then number of batches. This would be int xtrain.shape, which is present in index 0. Divide this by batch size. And then let's also add some noise here. So noise dimension. So it's going to be 100. And finally, for our optimizer, what we're going to do here is Adam. We just change the learning rate here. So LR, this would be equal to -4, and then beta 1 would be 0.5. So this basically means 0.0002. And now let's execute this. We are done. So what we're going to do now, we are going to create a generator model. So generator model. And here we are basically trying to do upsampling. So first off, as this is the model, right? So we'll give the name here as generator. We'll keep this as a lowercase generator. And this is going to be the sequential model. This is pretty similar to what we are going to have. So we'll have now generate. Let me just execute this. And now we'll have generator dot add. Now we'll add dense layer here. And now we'll call units. Number of units that I need over here, it'll be 7 times 7 times 128. And then we have input shape. And this would be noise dimension, comma. So basically this thing, noise dimension is 100, right? So this is going to give me the batch size, and then comma is basically telling me the values. And then again we have generator dot add. Now we'll do the reshape here. So it'll be 7, 7, 128. Then again generator dot add. We're going to add a 𝐏𝐸𝐬𝐿, and the value that I'm going to give here is going to be 0.3. That's the alpha value, or 0.2. It's totally up to you. And then we'll do some batch normalization just to prevent overfitting. So this would give me like the size over here is going to be 7 cross 7 cross 128. Now we'll try to decrease this and increase these values. So let me write that down. 7, 7, 128. We will try to do 14, 14, 64. So this is going to be generator.add. So we'll have convolution 2D transpose. Number of layers that we are going to add is going to be 64. Then we have kernel size, that will be 3 cross 3. Stride will take 2. And even after that, padding would remain the same. So now we'll do generator.add 𝐏𝐸𝐬𝐿, and we'll give the beta value here would be 0.2. And again, we'll try to add batch normalization. Now again, we'll try to do the upsampling. What we'll do is we'll change this. We'll change this to 28, 28, 1. This is the actual image that we need. So this is the size of the image that we have over here. So for this, we'll do generator.add. It's going to be the same thing that's over here. It's just that we'll change the dimensions. So instead of 64, it's going to be 1. And rest everything remains the same. And just a small change that I'm going to do here, add an activation function, tanh. This looks great. And finally, we are gonna compile a model. So generator.compile. So we'll have loss. This will be 𝐄𝐝𝐻. So what we'll do here, we'll also import 𝐄𝐝𝐻. So import just 𝐄𝐝𝐻. So now we'll come here, 𝐄𝐝𝐻 dot losses dot binary cross entropy, and then we have optimizer. We'll use our custom optimizer, that is Adam. We have used this Adam over here somewhere in the top. And finally, we'll try to do general.summary. That's our model.summary. And let's execute this now. So as you can see here, first off, we have the batch size. We have 7 cross 7. And finally, we'll do the upsampling and we get this image 28, 28, 1. Now we're going to do discriminator model, or you can say downsampling. The input size over here is going to be 28, 28, 1. If you're unable to understand what's happening here, I would highly recommend you to check out any of the Edureka's GAN tutorial projects. The reason for this is because GANs are pretty high level models that requires you to have some fundamental knowledge over here. So finally, what we're going to do, now we are going to do downsampling. So the input shape here is going to be 28. Let me just copy this from here. And we are going to downsample this to 14, 14, 64. So this basically we are trying to do the reverse of this model, generator model. So here we'll have discriminator, and this would also be a sequential model. And let me execute this so that I start getting the recommendations here. So now that we have done with this, so we'll have discriminator dot add, let's say conv2d, and now the number of layers I need here is going to be 64. Then I have kernel size 3, 3. Then I have strides. This will also remain the same 2, 2. We have padding. We want the padding to be same. And as this is the first layer, we are going to add our input shape as well. And this is going to be 28, 28, 1. So now that you're done with this, let's also try to add some other layers. So we have discriminator is equal to dot add. And now we are just going to add leaky ReLU and give an alpha value here to be 0.2. Try this with a different alpha values like 0.3 and whichever suits you. And now what we'll do, we will again do the downsampling. So we give this as a comment. And we're going to downsample this thing to 128, and this should be 7, 7. We're going to perform the same step. I'll just copy this for now. And as we all know, there's slight changes that we need to do. First off, instead of 54, this is going to be 64, right? Not 54. And instead of here of 54, we are going to have 128. And we don't have to provide the input shape over here as well. The rest everything remains the same. And finally, we will downsample this again from this vector to a scalar value. That is, scalar here is going to be 6272. And now we'll do discriminator dot add. So this is going to be flatten here. We'll do some discriminator dot add dense, and we'll pass here 100. And we'll also give some leaky ReLU here. Let me just copy this. And finally, we'll do discriminator dot add dense layer. And we just want the output for this to be 1. And the activation, as this is just 1, it's going to be sigmoid. So this is it about the model. And now we are going to compile this. So it's going to be discriminator dot compile. So the loss function that I'm going to use here is binary cross entropy again. So it's going to be 𝐄𝐝𝐻 dot losses dot binary cross entropy. Optimizer that I'm going to use will be Adam, the one which you have defined, Adam. And finally, let's compile this. This is not going to be compiled. This is going to be summary. And let's execute this now. So as you can see here, we are doing the reverse process of what we did in our generator. It's usually 28, 28. And then every time I pass this through a convolution layer, obviously there's change in size. And as I move down, the size decreases and we are presented with 1. So this is about like building our generator model and even our discriminator model. So fine, in the next stage or the final stage of model creation, we are going to combine it. Combined model. So over here we have describer.trainable. We'll give this as false. Then we have GAN input. So this is the name of a model. That's a GAN input. And I have input. And this will be shape. And this is going to be noise dimension. And then finally we have generated image. This will be generator of GAN input. And finally we have GAN output. This would again be discriminator. And we're going to pass here generated input or image. And now we'll use a functional API. We are using this to create a final model. So it will be model. This will be model. We are supposed to pass the inputs, right? So it will be GAN input. and the output will be GAN output. And finally, just like others, we have supposed to compile a model. That will be model.compile. So here loss we are going to use is binary cross entropy. So keras.losses not binary cross entropy, and optimizer will be Adam. Looks great. Let me execute this. The reason why we're getting this error is because of this, and let's try to execute this. And now as you can see, we don't have any errors. Let's quickly see how this model would look like. So model.summary, and let's run this. So as you can see, we have input shape, and this is the output, and then finally this is the input over here. So now we are going to come back to our data set, that's train. We'll reshape this. So it will be train.reshape. We're going to have -1, then 28. That is no on the x-axis, 28 on the y-axis, and 1 is a channel. And if I run this and add here xtrain.shape, you will see it looks like 60,000, 28, 28, and 1. This is the batch size, and then we have 28, 28 is the size of the image, and 1 is the number of channels. So this is all there is about building a model. Now finally, we are supposed to create a training loop. Let me give a comment again, training loop. So we'll have discriminator loss. At the same time, we'll also have generator loss. We'll have a for loop here for epoch in range, total epochs. Here we'll have one value, that is epoch discriminator losses. There will be 0.0. Similarly, epoch generative loss, and even this will be 0.0. So now we are going to have mini batch gradient descent for step in range, number of batch. Let me give some comments over here just so that it's easier for you guys to understand. So in the step 1, we're going to train discriminator. So for this, what we are going to do is we are going to have discriminator.trainable will be equal to true. That is, how do I do this is by this part. Okay, discriminator. So first off, we need to get the real data. So this will be index, this will be equal to np.random.randend. So we'll have 0, 60,000, half batch. And then we'll have real images. This will be xtrain present in that index, idx. And now get the fake image, or you can say data. So we'll have noise. This will be equal to np.random.normal. So we'll have 0, 1, noise should range. Size, this will be half batch, noise dimension. So now it will be fake image. This will be generator.predict noise. And now we'll do labels. So now we need the label. So it will be real y is equal to np.ones. So this would be half batch, 1 times 0.9. So times 0.9, and then fake y. This would be np.zeros. Then we have half batch, 1. So now it's time to train d underscore loss underscore real. This would be equal to discriminator.train on batch. So here we are going to pass real image and then real y. And then for the fake, d underscore loss underscore fake. This would also be the same. It's just that instead of real, it's going to be a y. So let me do this. Fake images, and then this is going to be fake y. And finally, d loss. This would be 0.5 times d loss underscore real plus 0.5 times d loss underscore fake. And then finally, we have to do epochs d loss, that is epochs per loss, plus equal to d loss. So this is the stage 1. In the stage 1, we are gonna just train this part over here. And now coming down to the stage 2, that is, let me give a comment here, train generator. And when I'm training generator, obviously my discriminator has to be false or disabled. So here we have noise. There will be np.random.normal. So here we are going to pass 0, 1, size. This would be batch size, noise dimension. And now we have ground truth. So this will be np.ones. And let's provide a batch size, the size for this, 1. And then we have epochs g loss plus equal to g loss. So finally, we have to print this out. So what we're going to do, we're going to write a function to display the images that we have created. But before that, let me quickly write here print. So it will be epoch, and we'll pass this data here. Then we have disk loss, that is discriminator loss. We'll provide this over here, and generator loss. We'll provide this over here. So here we'll have epoch plus 1, and then over here we are going to have epochs underscore d underscore loss. Divide this by number of batches. And finally, for our loss over here, that is generator loss, I'm going to add something similar. Let me give this on the next line just so that it's easier to read. So here it's going to be the similar thing, but instead of D it's going to be G. So let me copy this and paste this over here. And finally we'll have D underscore losses dot append. We're going to append the same value. So we are going to append this for the discriminator loss. We copy and paste here, and then this would be D underscore losses dot append. It's going to be G, not D, and we're going to add this value here. And finally, if generator, it's going to be like this: if the number of epochs plus 1 percentage 10 is equal to 0, then save it, give a extension as generator.h5. And now we also want to display the images. So what we'll do, display image, we'll write a function display image, and we'll just have to display this image here. So what's going to happen is, for every 10 images, so for every 10 image, it will display the epochs, losses, and then the images. For us to display the image, we have to write another function here. We'll do that as well. This will have a small function def display image images, and we'll give samples is equal to 25. Now we have noise. This would be np.random.normal. Here we'll have 0, 1, size. The size would be number of samples, that's 25, noise dimension. So generator image, this would be equal to generator.predict noise. And finally we'll just plot the figure here. So plt.figure, we'll give you a figure size, let's say 10, 10, and I want the images to be plotted next to each other. So for I in range samples, as it's 25, no, it's going to be 5 in row and 5 in columns. So plt.subplot 5, 5, that's 5 rows, 5 columns, and then we just have to provide the index, that's I plus 1. Then we have plt.imshow generated image, which is present in index I dot reshape 28, 28, and I want the C map to be gray. You can either keep it gray or binary, totally up to you. I'll give it as binary. Then plt.axis, we'll keep this as off. And plt.show, and yeah, this is it. So let me quickly give you a walkthrough of what we are doing here. Let me zoom out. First off, we try to get our data. First off, we are trying to ignore the warnings. Then we import the libraries. Then we get our data, try to reshape it. Over here, I want my data to range from -1 to 1. I hope now you understand why you're using leaky ReLU. And now we are trying to create the batch size, noise dimension, and customize our function. Over here, there are two models that are involved: the generator model, where we are basically trying to do the upsampling, and then we have also done downsampling using discriminator model. Both of these models are combined over here. As you can see, we are combining them to create a GAN model. That's our final model. And the way we train our model is quite different. Like usually we use fit and provide all the values, but here we are trying to write a customized training loop. For every 10 epochs, this function would be called, and this would actually generate the images. So let me do one thing. Let me quickly run this up now. Before you start, make sure you remove this comment from here. And first off, we are going to train our discriminator, as I mentioned earlier, and then we are going to give this a false, right? Discriminator.trainable would be false. And let me quickly run this and see what happens here. This would take quite some time, as training generators, adversarial neural networks are pretty intense. This would take quite some time over here, and let's see what happens. Alright guys, so as you can see here, we have successfully created our images. And now if I tell you this, right, this is not the image which is present in our data set here. This is the beautiful concept of GANs, where this image over here, we have generated this by ourselves. And this is what GANs does. So let's wait for another batch over here. Let's wait for another 10 batches, and let's see what happens and how that thing would look like. Alright guys, so as you can see here now, this is the second batch of the image that we have received. Let me zoom out a bit. Let me zoom out over here. So as you can see, the images over here are better. So we can see this 5, 6, 3, 6, 7, and all of these are the images that was generated by our model. And as you can see, all this is pretty simple and short, but there's a huge amount of complications that go in for developing this particular model. So if you have this kind of project in your arsenal, you can crack out any interview or question that is been posed to you. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!